So in this section, we're going to start talking about logarithmic functions. So this allows us to work with the exponent, on an algebraic level. Okay, so that probably doesn't make a lot of sense right now, but we'll show you how it works. A Richter scale is an example of something that uses a logarithmic function. So when you have a Richter scale is used to measure how strong an earthquake is. So we live in California, we have earthquakes, and so, sometimes there's a 4.3, earthquake or something. But if you had an earthquake that was like a 7.0 on the Richter scale, so say this occurs, I don't know, somewhere, and then you had one that was 9.0 on the Richter scale, well, it's not like it's 2 more. I mean, 7 and 9, that's a difference of 2, right? So 9 minus 7 equals 2. But that represents an exponent on a base 10, in this case for a Richter scale. And so it means 10 to the 9 minus 7, or 10 squared, which is 100. So this earthquake, and then you have this earthquake. So I think the book, this one is like in Haiti, and this one's in Japan. The Japan earthquake is 100 times stronger than the one in Haiti. Okay, so it's not 2 times or 2 more stronger. It's 100 times stronger. Okay? A decimal scale is also a logarithmic scale. Okay. So how do we do all this? Well, we've been working with exponential functions, and we had a function like f of x equals 2 to the power of x. And we spent some time with that function, and we graphed it. And we said, oh, it graphs to be something like this, right? So that's what that exponential function, this is an exponential function. And that's what it looked like when we graphed it. And we said the domain was all real numbers, and the range was 0 to infinity, okay? And it looked like this. Well, now we want to do the inverse. We want to switch the x and y. So, we've done that before where we wrote y equals 2 to the x, and then we switched to the x and y, and then we said, okay, solve for y. Well, how are you going to do that? Solve for y. You say, well, I want to take the y root of it or something. Yeah, that's not going to really work. So, because you have to get y by itself. So how are you going to work with that? And that's when logarithms were invented, I'm going to say. They allow you to switch that x and y and solve for y. So here's the relationship. If you have this, log base b, that's read log base b. So every logarithm has a base, okay? So log base b, it's a little super or subscript right down there. It just says, hey, that's what our logarithms are in terms of. And then you say log base b of c. This is a function, and it has to be a function of something. You can't just have log base b, okay? It's got to be of something. And it equals a. Well, then that means the base is b in an exponential form. The base is b, the exponent is a, and it equals c. All right. So it takes a little while to get used to this, but the base in the logarithm is the same as the base in an exponential function. So you want to switch between a logarithm and an exponential function. So you start out with the base b. Then you come over here, this is the exponent. It's the exponent on the base. So b to the a, and then it equals whatever you were taking a logarithm of. So it equals c. All right, so I'm going to go through this again because it's a little confusing. So the definition of a logarithm function for, first of all, x has to be greater than 0. So you can't have a number in here that's 0 or less. It has to be greater than 0. By the way, that x in the logarithm function is called the argument. It's what you're taking the logarithm of. You take a log of an argument. It's called an argument. And this book uses the parentheses around x. They don't all use the parentheses, but this one does, and that's fine. It's good. All right. And so you'd have an argument that has to be greater than 0. Your base, your little subscript here, that has to be greater than 0, and it can't equal 1, just like in your exponential function. And so you have log base b of x equals, y equals log base b of x. So here's your base, b, and then you go across to the other side to get the exponent, and then it equals the argument. Okay, so I'm going to write this one more time. Log base b of x equals y. Okay, here's how I convert it. Start with a subscript, b, then come over here and pick up the exponent, equals, or b to the y, equals, and then it comes here to the argument, comes back to the other side, x. Now sometimes my students tell me this looks like a snail, so it's like a spiral thing you got going. That's how you convert from a logarithmic equation, logarithmic function, but it's an equation, to an exponential function. And you can go from an exponential function back to a logarithm function, okay? So we'll practice some of that. By the way, the domain and range. Well, remember, these are inverse functions. These are inverse functions. Maybe I should write it down here. Inverse functions. A logarithm and a logarithmic function, an exponential function. And so their domain and range switch. So remember, for our exponential function, we had the domain was negative infinity to infinity, and the range was 0 to infinity. So for a logarithm function, I'll just put log function, the range is going to be from 0 to infinity, and the domain is going to be all real numbers. Let's see. Anything else I want? Did I just write that the wrong way? Yes. Oh, this was a long video too. Whoops. I think I might have said it right, but I think I wrote it wrong. The domain is 0 to infinity, and the range is all real numbers. Okay. We'll show you how to do this in the next video.